Hello viewers, so today we are formally starting the interactive session. I sincerely hope that most of your queries and doubts etc. you will be able to reveal in front of us, and to our we will try our utmost to clear all those doubts, so that you will be again able to deal with all the problems yourselves. So, to start with, in the interactive session, somebody has given the query, please list all the sources from which we can prepare for this course's exam. So, I have listed all the books which will be very much relevant for this particular topic and also for your GATE preparation. Okay. For example, the first book which is most relevant is Professor A.B. Chattopadhyay's Machining and Machine Tools. Second, Professor A. Bhattacharya, Metal Cutting Theory and Practice. Next, A. Bhattacharya, Principles of Machine Tools. So, A. Bhattacharya, please note there are two entries. One is Metal Cutting Theory and Practice, which deals with basically metal cutting theory, and the other one deals with machine tools in general. Okay. Please do not try to read up the whole book, only read up the particular parts which are relevant to the course, and those who are preparing for GATE, you can have the GATE general syllabus, and from that you can find out which parts are relevant. Then you have Ghosh and Mallik, which is a very good book. I mean, it is extremely relevant to GATE syllabus, because it has the solution of numerical problems with every chapter. So, you can make good use of this particular book. W.A.G. Chapman gives you, the workshop side of machining, that means details about machines etc. So, since this course is metal cutting and machine tools, the second half of the course will be well covered by these workshop oriented books. Next, you can also have from the net NPTEL lectures which have been previously recorded. They will be extensively covering material from this course. So, I have also given you the website address of those lectures. Next, in the second part of this course, under machine tools, we have covered different types of machine tools. For example, computer control of machine tools, and then non-traditional machine tools etc. Non-traditional machine tools you will find again will be covered by that NPTEL lectures, and also in Ghosh and Mallik manufacturing science. Yoram Koren, Computer Control of Manufacturing Systems, is a very good book on CNC, though it is quite old at this moment. I mean, it has been first printed in 1983, but it directly goes into the very basic technology of CNC. So, it will be very helpful for you for preparation. Kundra Rao and Tiwari, Numerical Control and Computer-Aided Manufacturing, that is very good. And Raghubangshi, a course in workshop technology. This book is very good from the point of view of, say, gear cutting, helical milling, etc. etc. Last of all, I have not included here, there is a book by P. N. Rao on CAD/CAM, that is also very useful when you are studying up computer control under this course. Okay. So, next let us start let us look at the next question. One student has inquired, what is the basic difference between the actual usage of feed rod and lead screw? The lead screw is basically used for thread cutting, and the feed rod might be used for longitudinal automated longitudinal cross feed, or automated I am making a mistake, automated longitudinal feed or automated cross feed, either this or that. It cannot be used for both at the same time. So, it is definitely not used for thread cutting, and generally we will not be really using lead screw for getting a good surface. No, it is used for thread cutting, lead screw for thread cutting, and feed rod for longitudinal or cross automatic feeding. Okay. This is the basic difference. And power is, how do we derive power from the lead screw? We derive power from the lead screw by a half nut. How do we derive power from the feed rod? Through the apron mechanism, which will be consisting of worm and worm gear, and then a cluster of gears, etc. etc. So, this way we derive power from the feed rod. Okay. So, this is the difference between lead screw and feed rod. In some lathes, in order to save money, sometimes they use the same shaft. Okay, the same shaft is used as the feed rod and the lead screw, that is, they cut a thread on a shaft, they also cut a keyway which is used both as feed rod and lead screw. Next, somebody says, I have a query that while I am, sorry, not this one, kindly help me how to pass the main certification exam easily with above 50 marks. So, I think you mean to say that I want to score marks above 50%. So, what is the way to do that? So, I can give you 4 very pointed suggestions which will definitely help you in scoring. Why 50? You can score towards 100%, okay, if you are really give time for this. That is, study the lecture material, do the numerical assignments and numerical problems in the lectures. Okay. So, as far as possible, complete all the numerical problems given in the lectures, given in the assignments, etc. If it is a rerun course, no, sorry, this is not a rerun course. Please solve the problems given in NPTEL lectures. Their answers most probably they are given, and most of the books that I have mentioned, they have a number of numerical problems given in them, most of them with answers, so that you can try them. This will increase your practice. Study the reference books provided. So, I have already given you the list, so you can have a look at that, and be careful about unit conversions. We live in a country in which inch system, metric system and what not, all these things are coexisting. If you think that okay, metric system is there and I will be having everything in meters, etc., you will be surprised. If you go to the workshop, you will find most of the time they are using half-inch BSW as the fastening thread. Half-inch BSW means it is in the inch system, British Standard Whitworth. So, you will find this to be very confusing. So, be very alert when you are converting units while you are doing numerical problems. Okay. So, next one, let us see thread cutting on the lathe. A student says that regarding lathe machine, it is known that it can be used for cutting threads. Does it use the same general cutting tool or different? It seems that the workpiece has to give different depth of cut, alternate, or there is something, etc. Okay. So, your main concern is how is thread cutting done on the lathe? First of all, you have to use a thread cutting tool, and it is going to be a form tool because it is going to be the conjugate of the thread profile that you are going to produce. If you are producing say British Standard Whitworth thread, you will be having a profile angle of 55 degrees. If it is metric thread, you will be having 60 degrees. If it is Acme thread, you will have 29 degrees. If you are having British Association threads, it is going to be 47.5 degrees. So, it first of all depends upon the particular thread profile you are going to produce with the cutting tool, and therefore, first of all it has to be a form tool. Generally, when you are using form tools, the rake angle should be 0. That means, the rake surface should be absolutely flat, so that during grinding you do not interfere with the particular geometry which is formed on the tool. So, rake angles would be 0, and also when you are cutting the helix, when you are cutting the thread will be essentially at a particular helix angle. This helix angle might be quite high, and therefore, you have to be sure that your clearance angle is more than this helix angle, or you will have interference. So, in order to avoid this interference, we generally have the clearance angle to be higher than the helix angle, and also the velocity, the RPM at which the job has to be rotated is generally, a thumb's rule is 1/4 of the typical cutting speed values that we use during ordinary turning. Okay. You can think about that, why that has to be done. And I should add here, when you are when you are repeating passes in order to get the full depth, generally we do not do it at right angles to the axis of rotation, but at a slight angle, so that the principal cutting edge takes the lion's share of the cutting and not the auxiliary cutting edge, because if the auxiliary cutting edge is participating too much, you have chips coming from that side and interfering with the regular flow of chips from the principal cutting edge. So, slightly the tool is shifted to the side in addition to the depth given in each pass. So, this is about thread cutting, but if you want to know in very good detail, you can also go through the books that I have referred to. Next, finding out N and C in tool life. Okay, suppose you are finding tool life, we have discussed a particular problem in the lectures, that is, if I give you 6 values of velocity and tool life, and if I ask you to find out N and C as is shown in this particular equation, then there is one problem. How do I find out 2 unknowns from 6 equations or 5 equations? So, in that case, what I have suggested, you will find in the lectures a method in which you can represent the equations first of all in log form. That means, you can take a log on 2 sides. Let me use this paper so that you can have a good idea of what we are talking about. So, we have v into t to the power n equal to constant, and we take log, so that we have log v, this is say natural log, plus n log t is equal to log c, and we claim that if we use log v and log t as the variables instead of x and y, this basically represents a straight line. Say log v is y and log t is x, then n stands for m, y is equal to mx plus c. So, minus n stands for m and log c stands for our c in y is equal to mx plus c. So, basically what we are trying to do is that instead of a representation of t and v in this form, okay, we are saying that in the practical case, I mean in real life situations, all these values of velocity and tool life combinations will definitely, or rather have every chance of not falling exactly along a particular relation of this type, v is equal to v into t to the power n is equal to constant, but we can have a least square fit. So, what we do is we turn to the log paper and we get a straight line representation for this log v, and therefore, these points which are experimentally obtained again appear this way, and we are going to get we are going to get a least square fit, which means the sum of the square of errors will be least, and for that the mathematics I have given in the form of a matrix. I have given in the form of a matrix, and this you can easily find out. This you can easily find out in literature. I can give you the reference of this literature, but elaborate deduction of this particular relation, that is the matrix algebra, mathematics that we have included in order to get the least square fit, that I think is beyond the scope of this particular course of lectures. Please accept for the time being that whatever we have derived, the way in which we have derived n and c is basically a least square fit. That means, we are going for the minimization of the sum of squares of errors. Okay. So, this is the way in which we have done it. If you would like to have it, I can send you a MATLAB program in which you will find that n and c can be calculated from a list of such combinations of v and t. Okay. Okay. So, let us see the next one. So, this is the pictorial representation that we have shown here, what we have discussed just now. So, this way we come to the end of the session of interactive questions already recorded in Google. So, let us have some of the questions. Yeah, in backlash elimination, if you are doing down milling, it is essential that we have backlash eliminated. Now, what does this mean? This means that, let me draw a figure here to show you. This means, say, let us take a very simple case. I have a body which is having a collar on it, and I am intending to move this way and that. Okay, some sort of reciprocation is required. I want to move it this way, that's why I have put a collar on it, and on top of this collar I have fit a fitting groove, not very fitting, it has a clearance which I intend to move, say by my hand. So, this is my hand, okay. Sorry, my hand got a bit distorted. I am having this one moving with my hand. So, these are the fingers, hopefully you can recognize your hand. So, I am moving this to and fro, but you will notice if I am moving to and fro with every reversal, since this clearance is more than the width of the collar, you will have some false motion at every reversal. This is called backlash. Unless you eliminate this backlash, you are never going to be free of this false motion that I am referring to here. Same thing with all mating parts which are in sliding motion. So, it also follows that if you have, let me draw a larger figure, if you have a threaded element, okay, these are the threads, etc., and this is the nut which is having, once again let me use a different color for the nut. The nut is having a slight clearance. You might say, why should the nut have a clearance? My answer to this is, suppose you have an ideal case in which there is no clearance to start with, but due to wear and tear at least you will have some clearance. So, whenever the screw, so I have not depicted the screw in full, okay, so it is like this. Whenever the screw reverses, it first has to rotate and ultimately get in touch with these surfaces, then only it can start pushing the nut on the other direction. So, first the nut is moving this way due to rotation of screw, and next the screw is rotating in the other direction and pushing the nut this way, and due to this gap it has to first cross this gap and get in touch with this nut. So, in screws also we are now establishing that there is this backlash due to the clearance. When you are doing down milling, these are the teeth of the cutter. Okay. I hope the cutter can be seen. Say the cutter is moving this way, and in down milling you are coming down the cut. So, if this is your job, it is located just on the nut, and therefore, this one job is moving this way. So, cutter is moving this way, sorry, the job is moving this way. The job is moving this way and the cutter is moving this way, and it is cutting material. But the problem is, the moment the cutter gives a push to the job due to the touch here, due to the cutting action, it will come out of contact here. It will, this contact which is keeping this push to this side due to the screw, this contact will be lost, because this push is so strong due to cutting forces. This nut will immediately shift to this side, and you will have a feeling as if the whole thing is made of rubber. That is, you are giving, say by hand you are rotating, you will find that there is absolutely no contact between the cutter and the workpiece. Why? Because the workpiece is floating in space, it is not in contact with the active side of the screw. So, if you want still to cut by down milling, this gap will have to be eliminated somehow, and you can have it by backlash elimination devices, which might be as simple as two nuts pressed away from each other by a spring, so that this nut grabs hold of these surfaces in intimate touch, and that nut grabs hold of the other sides of the screw in intimate touch. So, this way if you eliminate backlash, however much this cutter might be pushing, if this push is less than the strength of the force exerted by the spring, you will not have problems from backlash. So, that is why feed screws should be completely free of backlash if you have this problem. Okay. So, let us see whether we are having some other questions from interested candidates. If not, I can discuss some of the things which I have not discussed. So, this gives me a good chance to discuss it. The discussion on lasers was very limited due to, I have to admit, I did not do time management very well. So, lasers had been, I mean the discussion on lasers had been restricted to a very small maybe 5 minutes. So, I will quickly touch on the main points of the laser once again. We had discussed that the laser is a very good material removal tool, and also it's very versatile. It can be applied in other cases also, because it's monochromatic nature, and it's a phase definite phase relationship between temporal and spatial phase relationships allow it to be focused to a very small spot, and this gives us a very high energy density, by the help of which we can cut, I mean by liquefaction, by melting and evaporation, we can remove material, we can cut, we can drill, we can weld, we can heat treat, we can coat material, we can deposit material. So many applications are there. You might say, what's the difference between the laser and other material removal processes which employ power beams? Now, what are power beams? One very good example is the electron beam. You will say, what's wrong with the electron beam? Electron beam can be used in the place of the laser. The first and foremost problem with the electron beam is that you need a vacuum. So, if you do not have a good vacuum, the mean free path of the electrons will be very small, and you will find in most cases your cutting is becoming ineffective. You are not being able to cut with an electron beam. In the case of lasers, provided there is no very large disturbance in the atmosphere in between the lens and the workpiece, we can expect that very good focusing will be there, so that very high energy density can be obtained. Now, what do we mean by the laser being very versatile in comparison to other machining methods? Take the case of, say, abrasive water jet machining. Abrasive water jet machining is should be able to, we have heard, if you go through the reference books, abrasive water jet machining can cut practically all materials. Then what's so great about laser machining in comparison to abrasive water jet machining? We can replace laser machines with that. But the problem is, in abrasive water jet machining, we are still limited by the fact that it has a relation with the strength of the material. Laser is not. Laser is mainly concerned with the thermal properties of the material. So, if you have hard, tough materials, you will have a very tough time removing that material with the help of abrasive jet machining. Will it stop? No. But the cutting speed that you can attain for a particular thickness of hard and tough materials won't be that much compared to softer materials which can cut very easily, and you can attain very high speeds. And if you cannot attain very high speeds, you are not competitive. So, this way laser, if you compare it with different other processes, laser will prove to be much better than the other processes, much more versatile, and that is why it's gradually carving out its shape in the machining industry in a very big way. Okay. So, I will just end this discussion. Of course, if you are coming up with other questions, we will definitely listen to that and try to respond. But in the meantime, let me just touch another point. Rapid prototyping and layered manufacturing, these are upcoming technologies which are taking the help of processes like lasers, technologies like CNC, etc. Now, what do we mean by processes? For example, laser can melt material, and we are taking the help of this to melt powders and consolidate it into layered material, and then consolidate these layers together to get a particular shape. Now, what's so great about that, when we can already get shapes through conventional machining, the answer and non-traditional machining, the answer to that is that if you are building up a material in layers, there are some shapes which are very complex by non-traditional or conventional means of machining, but can be done very easily in this manner. and there are very shapes which are completely free form, like in medical practice if you are making bone implants etc., where shapes are not mathematically defined, but you have to deal with lot of data and develop surfaces from that data. There these methods are very much applicable. Okay. There might be pockets and regions on these workpieces which are inaccessible to physical tools. So, the complete absence of part specific tooling in case of rapid prototyping and layered manufacturing makes it very convenient for us, because we do not need any tool. We simply have the laser which is going to just melt and consolidate. So, that way it becomes extremely versatile. What about technologies such as CNC technology? In this case of additive manufacturing, we need to manipulate or make the workpiece move in the XY plane as we want. So, that asks for CNC machining, and we might have to rotate the workpiece about different axes of rotations in order to get access to different orientations of the job, which allow us to build up the workpiece according to our requirements. So, we will just have a small interlude in which okay. So, indexing, is that the first one? Okay. So, indexing, we have discussed simple indexing, we have discussed to some extent compound indexing, and we have also discussed something like a differential indexing. Now, what is indexing? Why do we at all require indexing? Indexing means that if for some requirement we need to rotate the workpiece by certain predefined circular angular rotations, we can take the help of indexing in case of conventional machining. Do we require indexing in case of CNC? No, but when we are working with conventional machines, especially operator controlled machines, in that indexing sometimes becomes absolutely essential. Let me give you some examples. One of the most common machine elements used in mechanical engineering is the gear. The gear has at regular circumferential intervals, we are having similar shapes cut out on the circumference of the on the pitch circle. Okay. These are called the teeth. The teeth are similar and they are having a equiangular pitch in between them. So, in that case what is to be done? If you have a method by which you can rotate the workpiece by small but equal angles, in that case our job will be done. We will go on repeating the machining process at these intervals. How to rotate the job? Why? We can buy a watch dial. Watches now cost you rupees 120, 150. You buy a watch dial, the dial of the watch, not even the watch. How much will that cost? 25 rupees. So, you buy a watch dial and fix it onto your job. Put a pointer against which you can rotate the job and clamp it into position. So, fine, you do that. The watch dial will at least give you how many divisions? 60 divisions, 5 divisions in between every count. So, 5 into 12, 60 divisions. So, what you do is 60 is the LCM of a number of prime numbers. So, what you do is somebody asks you, can you give me 5 divisions on the circumference, 5 equal divisions. So, what you do is you move by integrals of 5, 60 divided by 5, 12 divisions, minute divisions you move by, and you get 5 divisions. So, you could have done this by increasing the number of such divisions and satisfying all the prime numbers that we generally deal with. But the problem lies elsewhere. The moment you are doing this, you will be incurring something called parallax to start with, and you will also be unable to deal with fractions which deal with very large prime numbers, say 81. You might say, why are you choosing this number 81 just to support this particular argument? No, 81, 73 etc. These numbers are quite often found on gear teeth. Gears might well be having numbers of teeth in this region. So, it is absolutely not a very uncommon practice to come across such a machining requirement. So, whenever we have these prime numbers, this watch dial thing will not help you, which means direct indexing. Okay. You have the divisions already made up and you are simply shifting. So, even with vernier you cannot get much accuracy. So, from the point of accuracy and from the point of achieving a particular division, we see that it is not going to work. So, in these cases what do? We blow up or magnify the amount of rotation that you are asking for. Okay. So, you are asking for say 1 by 81st of a rotation, multiply it by 40, it becomes a very large number, and then you can divide it very easily into 81 divisions. So, if you have a problem in which suppose 81 divisions have to be made. So, first of all we understand, so I will select a new piece of paper. First of all we will understand that okay, fine, say 81. Oh, wait a minute, 81 is divisible by 3. I would like to take a number which is even more difficult, say 71. 71 divisions have to be made on the circumference of a circle, and what we do is we see whether 71 whole circle is present. Why? Because we will see in the indexing head 40 rotations of the index crank will allow me to rotate the workpiece once. So, if you want 1 by 71st of a rotation, you can get it from 40 by 71st of a rotation. So, if 40 by 71st of a rotation is required, if you have 71 whole circle, you can simply move by 40 holes on that. That is a possibility, but the problem is that 71 whole circle might well not be there. Why? Because we cannot simply accommodate all the prime numbers into the index plates. Index plates have a series of holes present on them. So, if that is happening, we have to go on for something like differential indexing, and in differential indexing we have a gearbox with the help of which we give a different rotation to the index plate. So, index plate is rotating, index crank is rotating. This differential motion gives rise to the required motion that we want to have. So, suppose you find okay 70 whole circle is there. I do not know whether we have done repeated, I mean we have done this same problem or not in our discussions, but this is an example of differential indexing. So, suppose you find that 70 whole circle is there. So, if 70 whole circle is there, what we can do is we will find that we can have a gearbox. So, the figure will be something like this. This is the indexing head, this is the index crank, this is the workpiece, and on the workpiece axis this is the gearbox, and this gearbox rotates the index plate. So, we will say that suppose we are able to rotate by 1 by 71st of a rotation, in that case this gets reduced by 1 by 40 in the worm and worm gear mechanism, and this one when it is fed back, this one is multiplied by u, and this one will be giving you the differential motion of 1 by 70 minus 1 by 71, which is 71 into 70, and here you have 1. A sign present here, if there is a negative sign present here, in that case it indicates that an extra idle gear has to be included in order to change the direction of rotation. So, here what do we want? Here if the holes are like this on the 70 hole circle, the 71 hole circle will be closer. Okay, let me use a different color on this. The 70, this is the rotation that you want, and this is the amount of rotation that this should suffer. Okay, the index plate should suffer this much amount of rotation. So, it is going backwards, and therefore, we understand that this will be, I will just cut this out and write it again, 1 by 70 minus 1 by 71 should be the amount of rotation. So, this is equal to 1 by 70 into 71. Therefore, this one will cancel and u will be equal to 4 by 7. So, simply using u equal to 4 by 7, this gearbox you can get this one differentially indexed and 1 by 71 rotation will be achieved. Okay. I hope this helps. If you are still interested in more examples, please write to me. I will try to help you as much as possible by finding out books which you can refer to with these examples. So, do we have another problem? Yeah. So, this is very interesting. So, in this case what happens is that when you are having chip velocity, shear velocity, etc., the first of all what we can establish is that the cutting velocity must be moving downwards like this. Next is say the chip velocity. If the orthogonal rake is 0, you can say the chip velocity must be having ultimately this direction. It flows along the orthogonal plane. So, if a particular velocity starting this way has been deflected to this direction, there must have been, you know, if you complete this triangle and if you get the parallelogram, the resultant, this must be the unknown factor which suppose we call as x. This x factor must have changed cutting velocity to chip flow velocity, let us call it chip flow velocity, and this is cutting speed Cs velocity. This must have shifted this velocity to this one by acting as the other force other velocity whose resultant is this one. So, obviously, this is equal to the hypotenuse and therefore, this will be the largest component. Even if you have the rake angle to be less, in that case the velocity triangle will be coming out this way. Vc rake angle, okay. This one must be the unknown velocity factor which is shifting the resultant to this direction. There is every possibility that this will still be higher depending upon the rake angle. And what is this angle? This angle is equal to shear angle. Rake angle is equal to 0 and therefore, if you can put in the values of rake angle and shear angle, if I remember correctly, you will get a relation of this type. Shear velocity is equal to cutting velocity into cos gamma divided by cos beta minus gamma, where gamma is the orthogonal rake and beta is the shear angle. Very commonly you will find orthogonal rake to vary from 0 to 10 degrees, maximum 15 degrees, and very commonly you will find shear angle to be around say 20 degrees, 25 degrees, etc., etc. So that there is every possibility that shear velocity will be higher than the cutting velocity. Now, why is that occurring? That is occurring because there is maximum deformation, okay, maximum shear deformation is taking place along the shear plane, and essentially that gives rise to the highest velocity in the system in that direction. Okay. So, do we have any other interested candidates? Question number 4, assignment 4. I can only discuss it because I cannot give you the answer because the last day of submission is still pending. Okay. So, assignment 4, question number 4, let me quickly see whether I can find it out from here. So, if I can log on to that, now how do I log on to that? Excuse me, can I log on to the assignment number 4? Oh, thank you. Okay. So, let us see, a lone Indian tank is protecting a border Indian town, but enemy army damages the tank gun steering system. Okay. So, the gun barrel which is there, it cannot be moved at all, but as you know the gun barrel has to point this way, that way in order to target. So, the commanding officer takes out the control unit, control unit of a containing pulse generator, position down counter and gates and drill axis table, axis drive of a CNC drill machine and fits it as shown. So, it is just a question of if this particular movement which was previously given to the drill axis table X drive, instead if it is made to rotate the gun barrel, in that case we have asked that, sorry it went out of, we have probably asked, if I remember correctly, we have probably asked for the the smallest angle by which we can rotate it, and we have asked basically the probably yes, the basic length unit we have asked for, and we have also asked for pulse generator frequency being the previous values of X drive, okay, speed and basic length unit we have asked for, the smallest angle of the tank and the speed of turning of the tank gun barrel. So, the first two questions you will definitely be able to answer from the basic concept of drill point to point technology, and the next two questions you just have to convert to the angular rotation of the gun barrel corresponding to the smallest rotation, the smallest step of the stepper motor, and you have to find out the speed at which this rotation can be done corresponding to the pulse generator frequency. So, if you still have doubts, I have extended the last day of submission. So, you will have a good time, I mean good amount of time to think about the problem, and I am very sure that with all the discussions that we have had, you will be able to do the problem. Okay. So, anybody else? Acha, how much time do we have? 7 minutes. Okay. So, since we have 5 minutes, if there are other students forthcoming, I mean if there are other questions coming up, otherwise I will discuss 1 or 2 points which we have left behind in additive manufacturing. So, in additive manufacturing, how is the question of CNC technology coming in? How does it help? First of all, it helps in selectively moving the table, I mean moving the table in a selective manner. So, we only melt a particular portion or we only cut a particular profile out, etc., from a reservoir of powder, or we deposit selectively, etc. All these things can be done with the help of CNC technology. Second, if due to any reason we have to tilt the table, that also can be done very easily online with the help of CNC technology. Rotation of axis and movements of axis with high precision, that can be done by CNC technology, which has made it possible for us to carry out additive manufacturing. Okay, there is one student saying that there is a question on a company making jewelry, that is it is making earrings with the help of helical gear cutting. They have chosen very small gears and they are cutting them, cutting helices on top of it, and they are again cutting helices of the opposite hand on the same earring. So, that a crisscross sort of cross check pattern is created, which might be appealing to some persons, and that is why this practice. Now, the question is, so in that case we have given some options, that is after you finish cutting of helices in one direction, okay, just a moment, I will just come back to this one. So, first of all, I will just come back to the question of that is it the this question is about that tank gun barrel, but they were saying question number 4, assignment number 4, question number 4. Question number 7, is it different? Question number 4, no, but this is different. See, they are talking about speed of gun, etc. Maybe it is a mistake. I am assuming that the question that you have asked is assignment 4, question 4. You have written question 7, but I am assuming it is question number 4. So, you have said that it is asked to find the speed of the gun, but speed depends on frequency. Then in that case, speed will vary with frequency. Do we assume the frequency by our own? So, I think some frequency must have been mentioned for the first case. If some frequency has been mentioned for the first case, we have to assume that. If I have not mentioned any frequency, then you cannot even find out the speed of the x-axis table. So, I think initially there must have been declared some frequency in the question. That means, it is having question 1a, 1b or maybe 1, 2, 3, 4. In question 2, please find out whether I have mentioned it like this, that is, if the frequency be 1000 pulses per minute. Yes, please notice here, if the pulse generator frequency is 1000 pulses per minute, the speed of the x-axis drive was nearest to etc., etc. So, unless otherwise stated later on, please assume that this frequency is to be adopted. Thank you very much, you have pointed this out. I will also make an announcement that in this particular question, you have to take this frequency if you have not already taken it. Thank you. Okay, a gearbox, just a moment, this is out. Yeah, in a gearbox, input and output speeds will generally be decided this way. That is, suppose in many cases we have given a gearbox between a motor and a table. So, when we are giving a motor and a table with a gearbox in between, the motor is feeding the gearbox. So, the motor speed will be the input speed and the output of the gearbox is being fed to the lead screw. So, that is the output speed of the gearbox. If I simply give you a gearbox and I do not mention which is the output side and which is the input side, okay, if that happens that way, in that case please understand that on the left hand side, okay, on the left hand side the input will be given and on the right hand side the output will be obtained. So, please look at the figure closely. I think I might have mentioned this in the assignments that I have given. If I have not given, if you can kindly send me a message on the forum, that is on in this particular case input side and output side of a gearbox has not been mentioned, I will definitely clear your doubt. Okay. The pattern of certification exams. The pattern of certification exam is like this. There will be 2 exams basically. Those people who are also opting for other exams, they might have a clash, and in that case you can appear for this exam on one of 2 different days. Which day you will be getting that information definitely from the administrators. Now, what is the pattern? The pattern is like this. Initially you will have 10 questions of instant recall type. What does instant recall type mean? It means that it is so much well known, the answer is so well known to you due to attending this course, that you will immediately understand what to write. You do not have to think, that is what. There is no time wasted for this instant recall type questions, 10 questions, 1 mark each. After that you have 15 questions. These 15 questions will be slightly difficult, and there you might have to do slight thinking, slight numerical calculations, etc. Next, so this is 10 plus 15, sorry, these 15 questions will be of marks 2 each. So, that makes it 30. 30 plus 10 makes it 40. Okay. Am I making a mistake? Let me quickly have a look. And after that, you are having 5 questions which are going to carry 5 marks each. Oh, right. 10 marks instant recall type, then 15 questions of 1 mark each, that makes it 25. And after that you have 5 questions with 5 marks each, and that gives you another 25. Okay. So, so that makes it 50 marks total. Now, what sort of questions will be this second batch, second section of 15 marks? Some thinking which you have to put in, some small calculations, and after that in the last section you have cluster of 5 questions, and within these 5 questions there will be small 5 separate questions, so that these 5 separate questions will be 1 mark each. So, in the last third batch of 5 questions, you basically have 5 questions, 1 set, 1 mark each, making up 5 marks, and 5 of such 5 mark questions will be there. That is why you will find, in order to get make you get some practice in those 5 mark questions, I have intentionally given some assignments in which there are questions related to each other with sharing the same data, etc. So, there quite a bit of calculations might be there, but since you are answering 5 separate small questions in under one particular head, those will be of sequential type, which will ultimately lead you to the final answer. So, you have every chance of scoring more in those broken up questions. So, auxiliary orthogonal rake and normal rake with sketch. So, let me draw this figure. Yes, just a moment, sorry. So, let us see what is auxiliary orthogonal rake. So, if we look at the tool from the top, we will see something of this type. This is the main cutting edge or the principal cutting edge, and this is the auxiliary auxiliary cutting edge. So, naturally, if we are talking about the auxiliary orthogonal rake, must have something to do with this particular edge. Next, orthogonal rake. Orthogonal rake essentially means that we are cutting this one perpendicular to the reference plane and perpendicular to the cutting plane. So, this is the cutting plane, trace of the cutting plane, it can be seen only as an edge. So, cut it this way. If you cut it this way, then we can get it somewhere here. So, if you are cutting it this way, we get this one as the section, and this angle happens to be auxiliary orthogonal rake. Okay. Now, for the normal rake. In case of the normal rake, what happens is, this is the cutting tool once again. If you have the tool this way, if we look at it from this side, we will be seeing the inclination angle appear this way. On the inclination angle, if we cut along this particular surface perpendicular to it, okay, this is the normal plane, and if we get this particular section, it will look somewhat like this. We are cutting it this way, I mean you are cutting it this way, and then this will be coming out this way. Okay. Just a moment, this means that this mark will be coming out here, this angle will be appearing here, this will be the orthogonal normal rake. Okay. So, this way just a moment, I made a mistake, it should be on this side. Okay. It should be on this side with this as the orthogonal rake, normal rake. Shall I draw a better figure? Will that be helpful? Okay. This is the representation of lambda, and we are cutting it this way. When we are cutting it this way, we get this as the depiction, and this is normal rake, okay, and this is the main figure. From here only we have develop this side. So, this is basically the cutting edge, this one, and we are cutting it this way and getting normal rake here. All right. Any other questions, or the time is up? In a gear shaper, the gear ratio UI has to be decided to cut a 2 module straight tooth spur gear of 33 teeth with a cutter of 2 module 25 teeth. The machine elements present between the cutter and the workpiece are shown in the figure. In such a case, in order to cut the above mentioned 33 teeth with the 25 teeth, the value of gear ratio should be nearest to. Okay, I cannot answer this question as it is probably an assignment question, but I can give you a hint how you can proceed. UI, when UI has to be found out, we have to remember that UI is decided by the number of teeth that you want to cut on the workpiece. How is this coming into the picture? See, if you are using a cutter with a particular number of teeth, say 20 teeth, and if you want to cut a gear with 60 teeth, we understand one thing, that if they are in mesh just as 2 gears, already formed gears, and if they rotate, then the cutter is going to have 3 rotations for every 1 rotation which is taking place for the workpiece. So, the ratio of the rotations will depend upon the number of teeth. Conversely, if we provide a definite ratio of rotations to the cutter and the blank, corresponding number of teeth satisfying that rotational ratio will be formed on the workpiece. So, keeping that in mind, UI will be essentially decided by the rotational ratio that you want, and the rotational ratio will be essentially decided by the number of teeth you want to cut on the blank and the number of teeth present on the cutter. I think I should not discuss anything more, because in that case I might be giving you some undue advantage in solving the problem with respect to students who are not listening in together with you. So, good luck. I think you can solve it.